So today we're going to start talking about what do you do if there's no right angle? What if it's not a right triangle? How do you deal with it? Many people don't realize that trig still applies to our oblique triangles. An oblique triangle is just something like this, where there's just no right angle in it. So we're going to label it angles A, B, and C, just like we did with our right triangles. Only now angle C isn't anything special. In the right triangle, C was always the right angle. Then, of course, the sides are labeled for the angle that they're across from. So this is side A, B, and C. Now, for people like me who are math purists, or math geeks, however you want to call it, you always go around a triangle counterclockwise, just like you go around the unit circle counterclockwise.
Why?
In calculus and some linear algebra matrix techniques, there's a method for finding the area of a triangle using its coordinates, but the coordinates have to go counterclockwise. If you go the other direction, you get a negative answer.
Now our coordinates always they go counterclockwise also.
Yes. Yep.
But I wanted to know why.
Mainly the reason is when they did navigation, that's the direction they went in. And all of the trig and stuff has been based off that. It's borrowed that navigational system for all of it. So anyway, we've already discussed the whole idea that whatever angle's biggest, its opposite side is going to be the larger side of the triangle. So the length of the opposite side is related to that angle in some way within each triangle. In fact, it's not directly related to the angle itself. You can't double the angle and then double the size of the opposite side. The length of that side is related to the sine of the angle, giving us something that's called the law of sines. So anyway, what the law of sines states is the ratio between the length of a side and the sine of that opposite angle is a constant in any single triangle. There's two ways to write the law of sines. I'm going to put it down the way I prefer to do it, or I prefer to use it, and that is this form. The length of side A divided by the sine of angle A is equal to the length of side B divided by the sine of angle B, which is also equal to the length of side C divided by the sine of angle C. In other words, that ratio of the length of the side divided by the sine of its opposite angle is a constant for that triangle. So what does that mean to us? Well, let's see that we have a triangle that is 18 millimeters here. Let's say this side here is 71 degrees, or the angle, sorry, and this angle down here is 36 degrees. You'll notice I haven't labeled any of the angles yet, A, B, C, or anything like that. I can label them however I want to. So I'll go A, B, C, which makes this side little a, little b, little c. So looking at this triangle right now, I know two angles and one side. Well, if I know two angles of a triangle, I know all three. How do I find angle C? I don't need any trig for this. There you go. 180 minus 71 minus 36, which gives what, 72 degrees? Is that correct? Somebody double check. Is it? 73? Okay. I found angle C here, 73 degrees. And all it is, they have to add up to 180. Pretty simple. Define sides A and C. First of all, which one of them has to be bigger? Careful. This is the biggest angle here. This has to be the largest side. Now, it doesn't really matter here since I know all the angles and I'm looking for the sides, but it's good to get in the habit of doing the longest side or the largest angle last. I'll show you in a couple examples here. So I'm going to look for side A first. From what I've been told you in this law of sines, side A can be found using that proportion. First thing we need is we need at least one side that we know the length of, and its opposite angle that we know the measurement of. Well, since we know all three angles, just any side will work. We know this side is 18. What's its opposite angle?
36.
Yeah, B is 36 degrees. This will be sine of 36 degrees.
18 divided by the sine.
Just hold on. Don't jump to punch it in your calculator yet. Let's set it up first, because there's a much easier way to do the calculation. Now over here, what side are we looking for? A. So A is, length A goes on top. It's
71.
sine of 71. Now the reason I stopped you from punching that in here, it's easier to cross multiply and divide than it is to divide first. So looking at this, you're going to cross multiply. 18 times the sine of 71 divided by the sine of 36. So 18 times sine 71, close my parentheses, divided by sine 36. Gives me 28.96 if I'm rounding to 2. Okay, let me talk through it. So 18
18 times
sine of 71,
71.
make sure you close your parentheses, divided by sine 36
Sine 36, both parentheses.
equals. So 28.955. Okay.
28.95.
So 28.96 is what it rounds to. So we know this side, 28.96. Now to find, oh, not wrong, where did I? Never mind. I hopped up on cold medicine today. 28.96. Yeah. Oh, allergy medicine, same stuff. So anyway, now to find side C, we do the same thing. 18 millimeters for sine of 36. C over sine of 73. The opposite angle for C is 73, so sine of 73. So the same thing here. 18 times sine of 73 divided by 36. Now, since 73 and 71 are really close, we know C is just going to be slightly larger than A. Yep, 29.285, so 29.29. So there we have all of our sides and all of our angles. This version right here is probably the simplest version of the ones we will do. So at this point, I'm going to put one up here for you and let you guys try one quick. Oh, I want that to let's do. So give that one a shot. Find the two missing sides and the one missing angle. I usually start out right here, getting that angle. Triangle adds up to 180. Minus 81 is 99. Minus 28 is 71. Okay. And that's exactly true. When working with any triangle, you have to have at least 3 pieces of information. And at least one of them must be a side.
Really?
Yes. Because if you have all 3 angles, well then it can, let's say you have all 3 angles. Well, it could be that, or...
Okay, I get you. Yep.
Be that.
So, at least one side, for right triangles, it's got at least one side and one angle.
And then we're on a 3rd piece of information.
Yeah, because 90 is a constant. Right. That's one.
You have the 90. So
That's
you
one of
need,
your 3 pieces.
so you have the 90-degree angle. That's one. That's your first 2, 3 pieces. And after that, you need either one side or two sides.
Right.
And then you don't need any other angles if you don't want, but you have to have at least one side. You have to have at least a total of 3 pieces. So on this one, let's finish her off. We got that angle. Give it down there.
So then that's the same ratio of 28 over 81, sine 81.
Yep.
And then
A over.
C is what it was. Or, sorry.
Well, now, here again, since A is the smaller angle, I always like to find the smaller angles first. Technically, 81 degrees is the largest angle in this triangle, so I don't have to really worry about that. In the next example, I will show you why that's important. So A over the sine of 28.
13.31.
Sounds about right.
It's actually 309.
Yeah, 13.309, 13.31. Then you do the same, 28.
Same thing with 71 degrees sine.
Got it. Perfect. 26.61 sounds right to me. So there we go. And then I always double check at this point, is my largest side opposite my largest angle? Yes. Smallest side opposite the smallest angle? Yes. Doesn't guarantee me I'm right, just keeps you from making really stupid mistakes. Remember one of those days where you just can't force your brain to kickstart and move. So there we go. So in this example, in the last example, we had 2 angles, which basically is the same as having all 3, because you can find the third one really quickly, and one side. Here, we have 1 angle and 2 sides. A little bit different case, a little bit more difficult to deal with. Now notice, we still have at least one side and its opposite angle. If we're going to use the law of sines, we must have that combination. From here, let me just label this quick. Really, not a lot of options as to where to start here. We have to start with 23 over the sine of 32. And equals, the only other piece of information we have is the 41 millimeters. And that's going to be over what? Sine of angle B. Good. Because B is its opposite angle. So we shall cross multiply and divide here. Sine 32 times 41. So sine of 32, close parentheses, times 41 divided by 23. 0.9446. What's that? Times 41 divided by 23. 0.9446. Perfect. Is that our answer? No. It's the sine of angle B that equals that. How do we find angle B then? There it is, inverse sine. B is the inverse sine of 0.9446. Now remember, that sine isn't 0.9446, it's 0.944638688. So rather than typing it back in, the best way to do this is you go second sine and then second answer, telling your calculator to use the answer from the previous calculation. You get 70.85 degrees. Get 70.85?
I got 8.4.
Close enough.
Calculator didn't do that.
So you had to tape it back in, so you lost just a little bit. That's fine. When we do a quiz or a test, you're going to have, you know, a plus or minus of like 4 or 5 thousandths of a degree. Now, at this point, we can find angle C. How do we find angle C? Yeah, you got it. We're going to take 180 minus 32 is 148 minus 70.85 is 77.15 degrees. So this is 77.15 degrees. And now we're going to repeat this whole process. 23 over sine of 32 equals C over the sine of 77.15. Where are those, Jason? You with us, Jason, or do you need me to slow down for a second? Let's check it out. 23 times sine 77.15 close divided by sine of 32. 42.32 I get. Perfect. Doesn't look like it's a whole lot more difficult, does it?
Of course, we haven't started stacking on top of each other yet. So.
We're not going to get that terrible. Unless you guys really upset me in the next couple of weeks. Now, remember I made the comment, always look for the smaller angle, smaller side first, leave the bigger one for last. Here, sometimes we don't have that choice. Here, I did because this is the angle that was opposite our second side. But sometimes we don't have that choice. And that can cause all sorts of problems for us. So let's say here we're given that this is 13 degrees, and this over here is 12 millimeters. It's just, the can't come on today. And let's say this over here is 26 millimeters. So we'll label this ABC, little a, little b, little c. Again, I have two sides and an angle that's opposite one of them. If it was this angle here that was between them, we'd be in trouble. We couldn't use the law of sine because you have to have a side and the angle that's across from it, or an angle on this opposite side. So we'll start setting up our proportion here. 12 over sine of 13 degrees equals 26 over sine of which one? B. So we'll cross multiply and divide. I don't know where my SI went. So sine of 13 times 26 divided by 12. We're at 0.4874. But remember, that's the sine of B yet. We need one more step to get B, which would be inverse sine of 0.4874. So second sine, second answer, 29.17 degrees. Now, if you're being careless here, you're going to write that answer down. You're going to move on with life. You're going to subtract 180 minus 13 and then minus 29.17. And you're going to get that angle C is roughly 137.83 degrees. Is angle C 137 degrees? No. Is angle B 29 degrees? No. Did I screw something up, make a big mistake? Not yet. Until I write down that 29, I haven't made any mistakes. Is this really the sine of that angle? Yeah, it is. This is part of what we talked about a little bit yesterday. When there's a sine, how many possible answers are there?
Two.
Two.
Because it could be
And there's one over here that has the sine of 0.4874. There's also one over here, though, that has the sine. How are they related? Yeah, this could either be 29.17 degrees Or this could be 29.17 degrees. They have the same reference angle, same angle to that horizontal diameter. So what would the real angle of this be? Perfect. 180 minus 29.17, or 150.83 degrees. 150 degrees makes a whole lot more sense here than 29, doesn't it? That actually looks right. So when we are doing these, we mentioned it yesterday, if you're doing an inverse sine, there's always those two possibilities, the angle itself or its supplement, subtracting it from 180. In this case, the picture made it very, very clear that that was an obtuse angle. So we had to do the supplement. If we don't have a picture, we have to be told, angle B is obtuse or acute, or greater than or less than a 90, however they want to word it at the time.
So your picture is always the reference point.
Yeah. And there are times, we talked about the tangent to a circle. Let's say we have a circle, and we have a line coming off it, but it's not tangent. Let's say it cuts through the circle like this, but we're looking for this angle right here with the radius of the circle. Is that going to be acute or obtuse on this side here? That's obtuse. Because if it was tangent, it would be a right angle. Since it goes like this, it cuts outside the circle here and inside over here. This one has to be acute. Because this is less than where the tangent would be. This one's outside the tangent, so it has to be obtuse. It has to be greater than 90. Make sense? So that's one of the things is you're going to have to dig a little bit on some of these to decide whether that angle is acute or obtuse. That's why what's that? Well, you knew it wasn't going to stay easy forever. Usually for me, easy lasts about 20 minutes, and then. So here, like I said, that's why I told you if you have the option, do the largest angle last. Because
we should be able to, as long as we are given
a picture,
visual, we should be able to look at it and tell, unless it's going to be
like 93 degrees. Yeah.
degrees.
Yeah.
We should be able to tell whether or not.
And most of the times you can't. But if you have a triangle that's like this, we don't know what that one is.
I would assume that that's not a right angle because
it's not marked.
Right.
Yes. But is it slightly larger or slightly smaller than right angle?
Well, larger.
You'd hope you're right, but if you're wrong, yeah. But if you have the option, find these two angles first, and then this one's going to be found just by subtracting from 180. You know there can only be one obtuse angle in a triangle. So you know that neither one of these can be bigger than 90. It just can't happen because they have to add up to 180. So let's give you guys another example here. So find the missing angles and the missing side. So where do we start?
150, yeah, over 121.
Perfect.
Yep. Cross
multiply and divide. So sine of 21 times 2.875 divided by 1.573. Oh, 7337, right? Gives us 0.60.
Now inverse.
0.6703, right? So it is inverse sine of 0.6703. So second sine, second answer. 42.09.
Subtract 42.10 from 180.
So Why are you subtracting it from 180? It's a obtuse angle. You need to supplement. It's 137.91 or 137.90, depending on how it worked out. That's fine. 9.1, I'm going to go with. Okay. So then we just subtract to get this angle. I'm going to trust you guys can get it from there. What'd you get for that angle?
21 degrees.
This one?
C is 1.537.
Yeah, it's actually like 21.09, right? So this is like 1.54 or something. It's
I
just
rounded,
slightly.
so I got they're the same thing.
Okay, so it ends up being just larger than 1.537.
Yeah.
Really close to it. It might even be like 1.539 or something like that. Really, really close. Now, I almost did this to you on this example. I didn't because, well, it's almost Easter. I'll be nice for now. But I was tempted to do this. Oh, let's say that this is 18 degrees. This side over here will go 19 millimeters. And over here, this is 83 millimeters. So we're going to set it up. 19 over sine of 18 equals 83 over sine of b. And we cross multiply and divide. 19, or sorry, sine of 18 times 83 divided by 19. We get 1.3499. What happens if you try to do the inverse sine?
Can't do it.
Why not? Yeah, sine can never be bigger than 1. What does that tell us? Well, that picture's messed up in a lot of ways. What it's telling us is if we have an 18-degree angle here, and this side is 83 millimeters, if this side here is only 19 millimeters, it's not going to reach back down to here. It's not a triangle. This side, whenever we get that sine being larger than 1, it's what we call an indeterminate triangle. It's not a triangle. You cannot, it doesn't connect. So something to watch out for.
Are you going to do that to us?
No promises.
Why would you?
Because I'm me.
Extra punishment?
Just when you see this, you've got to be able to tell yourself, okay, something's wrong here. And it's not my calculation. It's one of the dimensions is off.
So what happens? Will you get us like a system error each time you do that?
No.
Yeah.
No error.
Yep. Well, we've seen the case where we have two sides in an angle. The only that case almost always works unless what we do is we have like these two sides and the angle in between them. Well, then there's no way we can get an angle opposite one of the sides, so we can't use law of sines. This is what we're going to discuss on Tuesday, called the law of cosines. That's a little more complex. We've discussed where you have one side and two angles, and that's always solvable. Sometimes it doesn't look like it. For example, we might have a case like this, where that's 98 millimeters. Let's say this over here is 19 degrees, and this over here is 26 degrees. Looking at that, your first reaction is, we can't solve that. We don't have an angle on this opposite side. We do. What do you mean? You got 180 minus 26 is 154, minus 19 is 135. This is 130. Whenever we have two angles, we always have all three. If we ever have two angles and one side, we can always solve it. That is always the easiest case for law of sines, is two angles and one side. It's when we have two sides and one angle that we have all sort of problems. We either have this case here where we just can't solve it with law of sines, or we could have the case we just discussed where it doesn't really make a triangle. Or you have to decide, is this an obtuse angle or an acute angle? So that's the one that's going to give us problems, and that's the one that after today we're going to focus on. For today and your assignment for over the weekend, since I guys know that all you guys really have to do over Easter is to sit at home and do math homework. I'll I'll do you a favor so you're not bored. So, on page 381, I've got to give you a new packet. Problems 1 through 17. There's some in there that are just given in words without pictures. Most of those are talking about the two angles and one angle and two sides case, trying to determine if it actually is a triangle or not. I suggest you just sketch out a picture and label it. Usually makes it easier for me. So let me